Find the coordinate of the point Q on the x-axis which lies on the perpendicular bisector of the line segment joining point A and B. Name the type of triangle found by the points Q, A and B. First thing is, let's understand the question. First is your perpendicular bisector. What does it mean? Perpendicular bisector is a line that makes an angle of 90 degree and bisects the concerned side. Okay, and let me actually show this as well. So we have the first point is what, guys? -5 and -2. The second one is 4 and -2. And that would be your graph. It's basically a horizontal line which is obviously parallel to x-axis. Okay, let me just make it a bit bigger and relevant in the sense something like this. Okay, looks better. So now it will be easy for me to explain the logic. Okay, we are looking at AB is your points AB, and the perpendicular bisector will be something like this. First is I'll find the midpoint, so that would be point P, and then I should draw a perpendicular line, something like this. Okay, so it's passing the x-axis somewhere over here. We have to find this point, and this point is Q. So what is the funda? What concept should we use to find this? First thing is, yes, we have to use distance formula. That though you would have guessed it. All of you guys would have guessed it. So we have point A -5 -2, and point B is 4, -2. And now on to drawing the figure. So this would be your figure. So this is point A and point B. And now we'll consider a point P and then draw a perpendicular line. P is a midpoint, remember, and then join this. Say this point is on the axis. This doesn't look like midpoint. Okay, so something like this, right guys? Doesn't matter, it's just a rough diagram. So point Q, okay, since it's on the x-axis, this would be x, 0. I hope you guys are familiar with all of this by now. Now on to the working. So what are we looking at? So we are looking at point Q as Q is on the x-axis. The coordinate will be of the form x, 0. That is one thing that we can tell. Next, we have to talk about what concept we are using. We are basically using the distance formula. So why? Well, this is an isosceles triangle. Since QA as QP, sorry, P is a perpendicular bisector of triangle QAB. This implies triangle QAB is an isosceles triangle, right guys? And point P is your midpoint. Okay, so this we can mention midpoint of AB, and triangle of isosceles triangle. Okay, then what else can we tell? Yeah, where AQ is equal to QB. So with this fact we can find the value of x, right guys? That's it. So therefore EQ square is equal to QB square. And now just write the distance formula and we are almost done. So distance formula is x2 minus x1 the whole square plus y2 minus y1 the whole square to the power of half. So we have on squaring both the sides, on squaring both sides. Okay, so we have AQ. AQ is what, guys? A is minus 5 and Q is x. So x minus of minus plus 5 the whole square. Oh, I have written things over here. And we have the y component, that would be 2 plus 0, 2 square, guys. And QB would be x minus 4 the whole square plus 2 square again. I have the values written over here, so I'm able to see that and take it forward. And here we have 2 square on both the sides getting cancelled. And now we have to make use of a plus or minus b the whole square, which is a square plus b square plus or minus 2ab. And then we have x square plus 25 plus 10x is equal to x square plus 16 minus 8x, right? So we have x square that is common. Transposing and transposing here and there, we have 18x is equal to 16 minus 25. So this is basically 9 minus 9. So x is equal to minus 9 by 18, which is minus 1 by 2. We found the x value. Are we done? Let's have a look. Name the type of triangle formed by the points. Okay, we're still not done. We just found the q value. This is minus 0.5, I guess, and 0. It makes sense, right? We can see a bit over here, kind of a clue. So yes, it's negative. So now, how can we tell what kind of triangle it is? One is we are able to tell that it is clearly an isosceles triangle. If side AQ is equal to AB, then it becomes an equilateral triangle. That's it. Anyways, AQ and QB are one and the same, of the same length. So if AB is equal to AQ, then it's an equilateral triangle. Clearly, it is not an equilateral triangle from this diagram, but yes, we can't use this. We have to make use of the working and show it. So what do we have? We have, first thing is AQ is equal to, AQ would be what, guys? X 0.5 plus 5 the whole square. Or let me do this actually. Let's find AB first. AB is equal to, so what is A? It is minus 5 minus 2. And B is 4 and minus 2. So we have minus 5 minus 4 the whole square plus minus 2 minus of minus 2. So this term will become 0 to the power of half, right? So just let me put it down. So this is nothing but 0 and this is nothing but 9, right? 9 square is 81, square root of that again, so 9 unit. And then we have EQ, which is equal to 5 plus 0.5 the whole square. How is that I'm able to tell? We have the expression over here itself. Plus 2 square to the power of half. Clearly this is not equal to 9. You don't have to calculate it. We'll just tell it's not equal to 9 unit. Is it not? So therefore, as AQ is equal to BQ but not equal to AB, this implies triangle QAB is an isosceles triangle. That's it. So that was your question and that would be your answer. Again, here the funda is this, to show that or to understand why AQ is equal to QB. If you don't have this knowledge, then you won't be able to do this question.